What is a parity check for logical qubits? Imagine trying to find a tiny mistake in a huge, complex puzzle without destroying the picture. That's what a parity check does in quantum computing. It helps catch errors in the delicate dance of quantum bits, or qubits, without destroying their superposition. When we work with logical qubits, we don't just use one physical qubit. Instead, we encode one logical qubit into many physical qubits to protect against noise and errors. But errors can still happen, like a qubit flipping from 0 to 1 or vice versa. Here's where parity checks come in. They measure whether the number of physical qubits in a particular state, usually the state called 1, is even or odd. This measurement doesn't tell us exactly which qubit flipped, just that an error might have occurred somewhere in the group. Think of it like checking the parity of a set of coins. If you expect an even number of heads but find an odd number, you know something's wrong. In quantum error correction, these checks are done using special operators called stabilizer operators. They look at groups of physical qubits arranged in patterns, like in surface codes where qubits are laid out on a grid. When the parity check reveals an unexpected result, it signals that an error has happened in one or more of those qubits. This information helps the system decide how to fix the error without measuring the qubits directly, which would collapse their quantum state. Quantum error correction codes like low-density parity check codes use parity checks involving only a few qubits at a time. This makes the process faster and more efficient, which is vital for building scalable quantum computers. The goal is to keep the logical qubits as accurate as possible, even when the physical qubits are noisy or prone to errors. Performing these parity checks repeatedly allows the system to detect and correct errors as they happen. This continuous process keeps the logical qubits stable and reliable, making it possible to run complex quantum algorithms without losing information. Without these checks, errors would accumulate quickly, and the quantum computer wouldn't be able to function properly. In simple terms, a parity check for logical qubits is a way to spot mistakes in the encoded quantum information by checking the collective state of groups of physical qubits. It's a key part of quantum error correction that helps keep quantum data safe and usable. This process is essential for developing reliable, fault-tolerant quantum computers that can perform tasks beyond what classical computers can do.